So we're starting solving equations for variables. So in 3-4, we're just going to be doing one type of problem where always something was done to x. You have to either add or subtract to get x by itself. And that's kind of where we're going with this. I want to see you show your work. And here's kind of the reason why. I'll try to keep it kind of short. So I taught Algebra 2 for a whole bunch of years. I had some students that really struggled with this. And I remember there was one guy, his name was Dave. I was working with him after school one day, and he was barely passing the class. It was a large part of the year had gone by, and was working with him, and my thought was just, he's just not good at math. And I feel kind of bad saying that, but so I'm helping this kid after school. It's the first time we really did a lot of working together one-on-one, and we're working on stuff, and he's doing math in his head faster than I can. Like, not just like adding 2-3-digit numbers, but doing like multiplication of 2-digit numbers and stuff like that. And it's kind of like, how can you be doing so bad in my class and yet you're awesome at math? And what it is this. And I wouldn't write this necessarily yet, but he started out kind of like you guys. You get an x plus 4 equals 12. And he looks at that and says the answer has to be 8, right? 8 plus 4 is 12. And then they get it a little bit harder and say 3x equals 18. He looks at that and says x has to be 6. And then eventually, it gets tougher, so we'll do like a 3x plus 4 equals 27. And it's like, so he's still kind of like, okay. So he still could think it through, and he never bothered learning the steps. So now we're hitting Algebra 2, and you're getting this here. And it's like, now it's like he is sunk. He doesn't have any clue how to solve that problem because he never learned kind of how to do the little steps. So long story short, I'm going to be the obnoxious teacher that like collects the homework every day when we do these things, which is kind of nice because you know it's coming, so make sure you do it, check your answers, your grade goes up. But make sure you're showing your steps. I really want you to show your steps. Even though it's easy and a lot of you can just do it in your head, show your steps now so you know the steps down cold. So then in a couple years from now, when they start giving you really twisted and wrong things, you're like, oh, it's just one more little step, and you just do the math. Is that fair? Mm-hmm. That's kind of where I'm going. That's kind of the method behind the madness. This next thing, I don't think I'd write, but I feel obligated to tell you because it's in the book. So they have the addition property of equality, and I'm just going to kind of shorten it up to that. But what they're saying is if you have some number like a 5 is going to equal 5, right? Except for them, they use variables. They say maybe like x equals x or a equals a. But if you were to take this 5 equals 5, if I add 2 over here, and if I add 2 over there, if I add 2 to both sides, it's still going to be equal, right? It's just now 7 equals 7. So same sort of thing here. They'll say, okay, if x equals x, then x plus y equals x plus y. What they're really trying to say is you can add the same amount to both sides of an equation and keep it still the same. I'll maybe show you kind of the background to it. I wouldn't write this yet either. Say we know x equals 7. If I take and add 2 to x, I have to add 2 to 7 to keep it equal, right? So now I end up with x plus 2 equals 9. What we're really doing today is we're trying to figure out how do I go from here back up to there. That if I start out with this x plus 2 equals 9, how do I figure out what x was? And like we announced earlier this hour, most of you can just do that in your head. But the key is you look at what was done to x. Like right here, x isn't by itself. 2 was added to x, right? We've been talking about inverses in here, and inverse is something that undoes an operation. So what's the inverse of adding 2? Subtracting 2. So if we want to get back to where we started, well, they added 2. We have to do the inverse. Sometimes people think of that as the opposite of adding 2. Then that'll just make that cancel out, and we get that x equals 7, and we get where we started, right? So that's kind of the gist of what we're doing today. And this is where maybe I'd start writing stuff. So I'm going to say do the inverse operation. Or maybe say do the inverse of what was done to a variable. To get the variable by itself. And we'll have to add a little bit to that when we start getting like two-step ones. Sometimes they refer to that as to isolate the variable. Or you could say to undo what was done. And really, I just have a couple examples, and then we're done. So we're pretty much to the end of the notes. So if maybe my first example, switch to the blue, I'm just going to have an x minus 14. So there's some number x. They subtracted 14 from it and came up with 37. So we need to undo subtracting 14 to get our x by itself. So how do you undo subtracting 14? Yep. So the inverse of subtraction is addition, so we have to add 14. And so add 14 to both sides, that's going to make this cancel out. Gives us x by itself, and we have 51. So x equals 51. And in your homework, I told you I'm going to be collecting your homework and looking for steps. I'm looking for these three things. So first thing, rewrite the equation. So the book gives you a problem, write down x minus 14 equals 37 or whatever they do. Second thing, I'm looking for you to write down what you did to both sides of the equal sign. To keep it equal, you have to do the same thing to both sides of the equals. And then last step is write out your final answer. So that's kind of, as I collect your homework tomorrow, whenever this is due, that's going to be what I look for in determining, do I give you full credit on this assignment? And did you check your answers? So, do another one? So if I were to do a x plus 14.2, so x plus 14.2 equals 23.8. What do we do to both sides?
14.2.
Nice try. They added 14.2. Yep. So they added, so we need to do the inverse of addition. We subtract, so minus 14.2 from both sides. And then that drops out. X equals 23 minus 14.2. And I'm going to say 9.6. 9.6. Final thing, I'm going to skip my third example and just say this. One of the things that should be in your I can statements is you can check your answer. And you could, when you have a quiz on this, turn it in knowing that you got everyone right, if you check your answers first. So how you check your answer is this. Well, if this x value is really 9.6, we should be able to put a 9.6 in right there and get our answer of 23.8, right? So if they say show how to correct your, or show how to check your answer, they're looking for saying, all right, so I started out with x plus 14.2 equals 23.8, and there's a couple ways you could kind of show that you're checking. But so once you're there, then you could take and put a 9.6 in there, so 9.6 plus 14.2. So if I add those together, I get a 0.8 and then a 23. So you could kind of do it that way, you know, that, yup, look, it's the same. Or you could, if you wanted to, copy it down as an equal sign each time. So equals 23.8 equals 23.8, and then say like, yep, look, 23.8 equals 23.8. But you okay on checking? Mm-hmm.